Welcome. My name is Taylor Anderson. I'm going to talk today about the new assembly mass properties management tools in NX and how we've improved these here recently. We're going to talk about these agenda points as we go forward, a little introduction on the tools, and then some background on why we changed them and how things have changed and so forth. And we think you'll be excited about this here as we go forward. Little introduction. These tools here that we're going to talk about today are a significant update, as it says here, to the legacy advanced assembly weight management tools that have been in NX for the last 25 years or so. We put a lot of research into these adjustments. We spent several years talking with customers across really all of our major industries around the world, and looking at the unique challenges that each of those industries had relative to assembly weight management, and particularly large assembly weight management, and how those properties need to roll up and some different behaviors that need to be there. And so we think we've got a pretty good set of improvements here that you're going to like. This actually was released about 2.5 years ago, and since then we have not stopped. We've continually enhanced these tools since then. Of course, as part of the NX continuous release process, that's been happening every 6 months for the last few years, and we think you'll like what you see here. So with that, let's jump in and take a look at what actually happened. As we talked about how to change these tools, there were some guiding principles that we looked at. And these, again, evolved as we talked with customers around the world. But these were some of the important things that we concluded there. Really, really important one here is this concept that mass properties evolve throughout a product life cycle. Each part or assembly may have different values that we'll look at during the life cycle of the part, as we may start with things like budget allocations, mass property budget allocations, and estimates essentially of what things are going to be. Those may evolve into preliminary geometry that may have some properties that we can start to extract from the 3D model. As that 3D geometry gains fidelity, those estimates may get better and better coming from the 3D CAD geometry. At some point, there may be certain components that are purchased, for instance, from a vendor or incorporated from partners, and those parts that come over from vendors may have, it's common that those will have representative geometry in them, may not be fully detailed geometry, full fidelity geometry, and as such, the geometry itself may not generate super accurate properties, right? And so in those kind of contexts, it's useful for us to be able to assert mass properties to indicate what those mass properties should be and have those asserted values roll up in assembly roll-ups. And so we can do that. As we get even farther into a product life cycle, we may get to the point where we start to measure properties. And particularly if things are going to be flying, it's very common that we'll measure not just the mass of things, but some of the mass properties and inertial properties as well, to get very accurate look at the as manufactured state, for instance, of components. As we talked with a variety of customers, there were a number of other interesting states out there, some as shipped things or with fluids, for instance, or other kinds of states that customers wanted to be able to keep track of. And so we've done that here. As we've redesigned the assembly mass properties tools, we've included some ways to include really all of those values along the maturity of that part, starting again with those initial estimates out through the CAD geometry, the as designed CAD geometry, potential assertions, asserted values that may be in there, and then a number of user-definable states, or really company-definable states that you may want to keep track of, things like, again, as manufactured, or including fluids, wet, dry weights, for instance, as shipped, and so forth, that we can start to keep and roll up and give you some automated tools for finding the best values or the most mature values out there that you want to look at and roll those up in automatic ways, right? So several of those values may be useful at different times, right? You may want to look at those and change between those at different times. We found talking with customers, and so we've got a very robust set of tools there that I think you're going to like. We'll see that here in just a minute as we go through there. Okay, we recognize that assembly mass properties is a mission critical task for a whole bunch of our customers out there, and so as we've done that again with this redesign, you see 4 kind of bullets there. We wanted to make those part and assembly mass properties a lot more visible and bring those to the designer's fingertips, really, to be able to browse and see those very, very quickly as we look through both large and small assemblies. Similarly, the second one I mentioned here, described in a bit of detail there, we're preserving those multiple property values really across that life cycle, right? We're going to allow users to choose the best numbers there as you work. A lot of more visual interactive feedback that you'll see as we go through there. That's going to include not just things like validation results. So if there are checks that are happening on mass targets, for instance, property targets, we can see those validation results very clearly, as well as things like center of mass markers that may be present in parts, and we can again see those very clearly here. You'll see in the new tools. Last one here is really improving the consumption downstream. So a couple of things here. One of those is things like associative expressions, if they're desired, to be able to create those to consume some of these mass properties downstream in other processes, as well as things like our reporting tools. So the reporting from mass properties used to be a pre-configured spreadsheet that would get generated. We've got a lot of configurability to that now, and we'll see that here in the demonstration in just a minute. Okay, quick overview of how the user interface has changed here as we go into this. There are a variety of things that we've adjusted here. So this is NX. This is the latest version of NX here, and we'll see a few of these things. Just a quick overview here, and then we'll see it live in the demonstration in just a minute. But for reference here, we've added a toggle button here that's on the analysis toolbar to show these mass properties panels. And these panels are going to show up in the assembly navigator, and there's actually another one in the part navigator now as well. It was not in the initial release, but was in the second release and on. And so these will show this mass properties panel inside the assembly navigator here, for instance. This panel, if we toggle that off, goes completely away. So it doesn't take up any real estate if you're not using it. But when you are using it, it's there and very closely associated with the assembly navigator, which is going to be super useful. You'll see here in just a minute. There's some buttons there, as you can see, for updating the mass properties. We've intentionally made that mass properties update a delayed action. We don't do that immediately when changes are made in the model, because can be a relatively heavy operation. We're going to Parasolid for a variety of detailed mass properties there, and depending on the amount of geometry or the either in terms of a large assembly or very complex components, that mass properties calculation with high precision can sometimes take several seconds. And so as a result of that, we've chosen very intentionally to have this be an update that's going to be user initiated here. So we'll let you do that very easily. If you're in this mode, you're looking at mass properties here, you can poke either one of these buttons and get the same kind of response here, where you'll get an update of the properties for the things that are selected out there. So with that, a couple more things. Context. You'll notice down here in the panel that as we select something in this assembly here, there's one of these sub-assemblies out here in the middle that's selected here. A few things are happening. You'll see in the panel there at the top of the panel, it's describing some context, that there are 12 components selected here. Inside that configuration context, right below that actually is some more information about exactly which reference sets are being used, if there are component groups or things like that involved in the selection and so forth, to make it very clear what we're looking at as we do these selections. Out in the graphics area, you'll see a little green center of mass marker that's out there on the selected components. So there's a new set of center of mass markers that are available out there for a variety of contexts. Either for the displayed part, you can have kind of a persistent red one that's out there. This green one is one that's a combined selection. So anything that's selected out there will aggregate the properties of all of the selected things and show a center of mass marker out there, for instance. And there are a couple others available as well that we can see in a second. Mentioning that set of collected properties, this is the same thing that's happening here actually with the things in the panel. So as you saw there, we've selected this subassembly that has 12 components in it. The properties that are down below are the aggregated components for these 12, or aggregated properties for these 12 components. We can do this really with individual selections. We can do control select and shift select to very freely select one or more components up in the assembly navigator or the top level assembly to very quickly see the properties of really any sliced or diced subset of the assembly up there. If you have component groups defined in your assembly, again, selecting those component groups will of course select the components in the component groups, and again the mass properties will roll up very quickly for those component groups as well. So super handy context there. Okay. Last thing out there, there is an up-to-date status indicator that's down here in the mass properties panel for the selected stuff. In this case here, the subassembly is completely up to date, and so it's got a nice big green check on it. All of the components inside it are also up to date. You'll notice up here in the assembly navigator that there are several kinds of up-to-date status or status icons available up there. We'll see these again in the demonstration in just a moment, but the checks, of course, are an up-to-date symbol there. The slash here is actually a suppressed component, so it's not being included in this particular roll-up. You'll notice the mass is blank for that one as well. We can certainly do that to include or exclude components from the mass roll-ups. The question mark is an out-of-date one, where there's been a change made to some geometry or something down inside this assembly, so this one needs an update. The red ones are ones that are violating one or more of their checks. So these particular ones are a couple of components that have components that are out of their mass targets, right? Actually, even at this assembly level, there's a mass target that's being violated on this particular one, and so we can see that kind of indication very clearly here. These statuses will reflect down here as well. If we select those, we'll see those mirrored down here. Oh, little finger down here as well is the asserted status down here. So there's a component or this assembly that has an asserted mass on that as well. So these kind of statuses will be handy as well to understand what's going on in the context of the design. Okay. Good. With that, there are a whole bunch of things we've done since the initial release. So we've described a bunch of the initial release things. I'm going to go through these very quickly here, and we can see some of the highlights of these. There are 4 slides of these because there have been basically 4 releases since the initial one out there. These roughly correspond to those 4 releases out there. We added some new columns in the assembly navigator for the center of mass. There's a combined one that shows kind of XYZ together like this down here in the lower right. It shows X, Y, and Z coordinates in the context of the displayed part. We also can display those individually. If you're concerned about a particular one of those coordinates, certain industries have a direction that's the most important direction that they're concerned about for a variety of reasons. We can look at just one of those coordinates if we want to as a column independently here as well, which is nice. We mentioned those center of mass symbols that are out in the graphics area. Again, we may have multiples of those out here. In this case here, this is actually showing kind of 3 at the same time, and there's a red one that's for the displayed component, which is for the displayed part, which is the entire model here. And as you might expect, that one's roughly in the middle of that large subassembly there. The green is, as we saw in the previous screen, for selected components. And in this case, there are a couple of components that are selected. And the blue ones here are actually individual CG or center of mass markers on the selected components. So it's a little simple example here showing all 3 of these at the same time, right? Where red is showing us the big context, green is showing us the combined selection context, and then blue is indicating each of those. And we can turn each of these on or off individually out there depending on how you want to work. There are some legacy options for non-standard reference sets out there that we have some ways to handle, of course, the legacy mass data that's in your parts and assemblies out there. Really nice new visual reports. We'll see this in just a moment in the demonstration for looking at mass properties and understanding these in a very visual way. As well as a new panel in the part navigator as well, not just the assembly navigator, but really nice fine-grained control of individual body properties out there. So we can look and see very quickly which bodies are in or out of the reference set that's being used for mass properties. See the individual properties of those bodies. We can assign materials and assert properties on each of those individual bodies and get a part level and a preview of exactly how that part is going to look and how it's going to roll up in larger assemblies, which is super, super handy at times. Coatings was another big application that came through here as we added the coatings application inside NX to be able to apply paints and coatings to parts. Those, of course, come along with mass and volume. And so those masses and volumes of those paints and coating layers can start to contribute. And so you'll start to see a from design coded status that can appear inside the mass properties roll up down here. And we'll be able to roll up those with coding masses if we want to out there. Let's see. Another thing that came a little bit later was this configurability, as I mentioned, of the mass property reports. So here again, we used to have a fixed Excel output format for mass property reports, or for the older assembly weight management tool. And we've allowed a whole bunch of configuration. You can choose which properties you want to have actually displayed on that, and output that very, very cleanly now. In not just Excel, but also into some other formats, XML and CSV and so forth. If you're consuming those downstream in more programmatic ways, we can put those out in very interesting formats that can be consumed downstream. Okay. Let's see, a couple more things. Accuracy settings. We did some simplification of the accuracy settings, and we've got a whole bunch of data behind what we did here. If you're interested in seeing that, the source precedence we'll talk about in just a minute, but this is that ability to really choose which of the sources of information are the most mature out there, or predictions or targets might be the least mature. You might have, preliminary CAD geometry or the from design numbers might be the second, and then again you may decide that asserted numbers are better than the CAD numbers, right, or more mature than the CAD numbers, and again you may have things like as measured or as manufactured states out there that are the most mature in your mind. But you can choose that source precedence, and again when we export the report, we can make sure the report is clear on which ones are being selected and why. This is a special case out here if we're working with associative expressions that come from mass properties. It's a new ability to do associative expressions. We'll give you some fine-grained control there. The last one of these, the 404 here, is the most recent, of course. We've got some better display of the center of mass symbols. They would hide inside the solids at times in some earlier releases, but those display much better now. And we see some more things in visual reports, and then some more configurability in user-defined attributes in the output reports and so forth as well. There's also a quantity attribute for assembly components out there that we can support optionally as well. But at any rate, lots of those out there. There's a fun demonstration here that I want to go through some of this live and show this to you. So let's do that. We'll switch over to NX. This is my handy chainsaw assembly that I use a lot for mass properties demonstrations. It's got a bunch of good stuff in it. As you can tell, as you can see, there are lots of mass statuses on this particular one, as we saw before. Some of those are out of date, of course, but we can come in and update those when we want to. Showing those mass property panels, again, there's that toggle button that's going to turn those on or off out there for us. And again, as we select really anything out here in the assembly navigator, we'll start to see either that individual component out here. As I mentioned, there's context here about which reference set is being used, whether they're assembly groups or arrangements or coatings or things like that that might be influencing that particular number or set of numbers. If we're selecting assemblies out here as well, we're getting those assemblies. Here's that one with the center of mass marker out there in the middle. Really all of these, of course, you're seeing that center of mass marker out there, right? And similarly for the top level assembly, we can do that as well. With these, again, the values that are down below are going to be the aggregated properties of the parts that are there. And so with these, we can choose which source we want to use for these numbers. There's some that we'll see, for instance, here, this assertion in there, right? And this assertion is happening. We see the assemblies at From Design that tells us that this assertion is happening at a lower level. So we can go in and look down there in that component, for instance, and see how that's happening. So in this component down here, we can see that, again, there's an asserted source that's selected here. If we slide over just a little bit, that From Design value is this 0046 at the moment, and that's being asserted to 005. So someone measured that and decided that it was 005, and so we're going to use that value instead. One interesting side effect of this that we can do is as we do those assertions down there, we can also be, let's see if we come back to From Design here, for instance, and go look at like our center of mass, our inertial properties here. You can see that we've got 0.1644 right now, for instance, for the XX component of the center of mass, or sorry, for the moment of inertia. And as we switch that from as designed to asserted, what we're going to see is that these can scale down here as well. So that these properties will, as the mass scales, these inertial properties, really all of the inertial properties down below here can scale as that mass component is changing of those values. So we'll do that as we change this to as to asserted here, for instance. We see that those numbers are slightly scaled up, right, based on the proportion of what's happening there with the mass. And if we do a big one there, right now it's 005, and this is 17, 20, 30 here, we can see we take that assertion there and double that, for instance, 0.01. We'll see that these individual properties update immediately here as we do this, right? So really nice ability here to calculate, recalculate, get scaled properties for the inertial values that are all things that we were not able to do easily in the past, right? You'll also notice, of course, it's second nature at this point, but all of these assertions and things are happening right here in the table. So extremely easy to edit those and to get at these values and understand what's happening with those at any given moment. Okay. With that, let's close that guy down and come back over here. Let's see, we have some of these properties that are out of date at the moment, so let's go ahead and update those. So again, here or here, either one of these will give us an update in this assembly here. And we see some things rolling up. There's some masses that are out of the zone here. We can see if we want to go and adjust one of those, we can do that very easily. Drill in here until we find, say, the offending component in there. That guy is one that's outside its mass limits there, and so let's go look at that for a second, right? Let's go take that. We'll look at this in its own window here for just a moment. And likely, I know the problem here, of course, because I created the problem on purpose, but our problem here is a material problem, right? As we go to look at the materials for this particular body right here, we're going to find that this is made of tungsten, right? Which is not what it's supposed to be made of. That's far too heavy, which is why it's outside its mass target. If we look at the mass properties for this part here, for instance, we'll see, let me update that really quick. There we go. Right now it's at 0.446, and its target out there is actually 0.1. So it's about 4 times as heavy as it should be right now. So let's change the material. As we do that, let's go grab a nice aluminum for this instead. We'll assign that, and as we change that, again, the mass properties are not going to update immediately. We're going to delay that update until we get a refresh. And once we get that refresh, then we'll see that now our mass is this 0.06. We're inside our target there. We're not violating that limit anymore. This is green instead of red, and that's all good. So as we come back to our assembly here again, we'll poke an update here, and we can see that start to ripple up. So that parent assembly is green now as well. There's a very similar thing happening in this component right here. We'll do the same kind of thing here. Open this guy up, and again, it's showing red at the moment because it's out of spec. And we'll do the same thing here. Come in and change that to a nice 6160 here. There we go. And as we do that, then that one will also go green, right? So that's happy. And again, as we roll up the assembly there, we start to see that progressively turning more and more green as we go upward. So with that, that's a good look at those bits. The other thing I wanted to show here is, yes, the like in the Assembly Navigator. For instance, in the Assembly Navigator, we've had for some time the ability to come in and configure the columns that are in the Assembly Navigator, turn on and off various columns out there. Those center of mass ones are in here by default now. We've also had the ability in here to specify custom attributes, part attributes in here, for instance, to be included in here. So for instance, I could come in this assembly and say, for instance, that I want to have a cost attribute that's out there that I want to display out here. And that'll add that as a user-defined attribute column out there. And as we turn that on, of course, that'll add that column out there in the Assembly Navigator. And there are a smattering of parts out here at the moment that have that actually assigned. Those little nuts do down there. We also can do the same thing now in the mass reports, right? So if we have our assembly selected here, for instance, and we go to export mass data, here we have again the ability now to configure this report, choose which information we want to have in the header, choose which information we want to have out there per component, and the display name or the file name or descriptive file name, how we want to see these described in the report, and then choose the individual properties that we want to include out there in the report, including, if we want to, the source, right, where those are coming from. This is coming from the CAD geometry, or is this an asserted value, or is this coming from a measurement, or where, right? We can understand exactly what we're looking out there if we want to. So all those properties are out there. New one that's included more recently is material. So that can be part of that export now. That was not part of the legacy tools, and that's good as well. And as I mentioned, we can also start to include these custom attributes now in the export mass reports here as well. So we can go and very similarly go and select, for instance, that cost attribute, and then include that cost attribute somewhere in our report here as well. Of course, moving this up and down if we want to. Again, exporting that either to the information window or to Excel, or actually some more data-driven kinds of outputs that may be useful for downstream processes for you. Okay, we can save those templates off and have those available for reuse across a company, so you have consistent results coming out there as well. And of course, that's all configurable in your customer defaults to set that all up nicely. So for the sake of consistency, right? Good. Let's look really quickly at visual reports. If we go over into visual reporting here, we'll start to see what do we have in there now. Body materials. That's kind of a fun one in an assembly like this. We've got lots of different materials out there in this, and of course, we're using visual reporting to see those various materials out there in the assembly. Right now we're in the explore mode here, where we're looking at individual components out there, and the assemblies don't get in the way. And if we switch this to some of our mass ones, there's a mass source type out there that's a handy one, where we can see for an assembly which components are using the CAD numbers, the from design numbers out there, and which specific components out there are asserted, right? And this particular one, we've got certainly one out there, and probably some others. I got to look at that a little closer. The other one I want to look at here is the mass status. This one's a really, really handy one here. So particularly if we're working along, right now I updated everything, so everything's okay and asserted here. Let me go and reopen this here just for fun. So we've got a little more variety in the visual report, and we'll see a little more interesting output on that one the second time here. Let's grab that same assembly right there, and this should be saved in that that state where there are some things out of date. There we go. And as that comes up here, sure enough, we see this now the second time with most of the parts okay, but there are some that have some asserted properties in there showing up. There are some that are outside their mass limits, those ones that we fixed a minute ago, as well as some here that are showing that they are unreliable, right? The cache is not found, or they're out of date. So we can see those individual components out there that need updating. Okay. So with that, let's switch back and finish off the presentation here. Right here. There we go. Good. So as we look at some of these benefits here, of course, as you've seen in the demonstration there, we're seeing those mass properties at the designer's fingertips now. Those were harder to get to before, right? All of those inertial properties and things for the assembly were really, you could output them into Excel and take a look at them there, but it was not easy to browse through those in assemblies prior to NX 1899, a couple of years ago, December 2019, when we released this first. So we think that's very useful. Again, multiple values. You can see we've done some things with that as we preserve those across the life cycle. Visual feedback out there as well. Very clear now. Some interesting things going on there. And again, better availability of these mass properties downstream in terms of associative expressions and the reporting properties as well. Okay. Good. Couple recommended practices. Conceptually, here's an analogy, right? If you like to have a clean kitchen counter and to have all the dishes neatly tucked away at night, you need to wash the dishes consistently, right? I grew up with a lot of siblings. If you have a big family, getting stuck doing the dishes all by yourself is a lot of work and can be really frustrating at times, right? Getting everyone to clear their own place and to put their dishes in the dishwasher goes a long way toward lightening the load. Sometimes there are a few pans that need to be washed by hand and things like that, but that's not too bad, especially if everybody pitches in and helps, right? Now, if everyone's not in the habit of helping and the dishes start to pile up, then getting the kitchen back to normal is going to be a lot of work for someone, right? And nobody wants to be the someone at that point. And so the moral of the story, of course, is that many hands make light work, right? And that's going to be true for mass properties as well, particularly on large assemblies out there, right? Robust management of assembly mass properties is a thing that's much harder to do after the fact or at the end. And talking with our customers who are successfully hitting their weight and balance requirements, we observe them involving all of the designers in actively monitoring mass properties throughout their product development. They often have a responsible mass engineer or sometimes multiple people who oversee the roll-ups and extract those high-level metrics. But successful companies don't leave this one individual to do everybody's dishes, right? Many hands make light work here. I recommend that you automate everything you can here. There are a bunch of things we give you there. I encourage you to check out the customer default options carefully and to set those site-wide as needed. That's very, very useful to look at those, and we're happy to talk with you about some best practices specifically there. One of these is the model reference set or the mass reference set. This is the model reference set by default. NX likes the model reference set by default if you can stick to it. It's really important to recognize that NX uses reference sets for two very distinct things. One of them is for limiting display. So in the assembly navigator, you may be familiar with the concept of changing the reference set to display, show, or hide various objects that are in individual components out there. That assembly navigator usage of the mass reference set, or of the model reference set, is specifically for limiting display, right? Usually reducing the display to a subset of things for faster performance out there. There's a distinct usage of that reference set for mass properties, right? And this is more of a site setting where you're going to be looking to the contents of a particular reference set for calculating mass properties, regardless of what's displayed at the moment, right? So a little distinct usage there. Showing and hiding things in the display should not be changing the mass properties, we think, and customers have agreed. And so little important thing to understand there relative to mass properties. And again, those two distinct usages. The one is the limiting display, and that's going to be that interactive switching of the mass reference set, the model reference set that you may do in the Assembly Navigator. The second one is that changing of is a much bigger deal, right? Of changing the reference set that's used for mass properties, and that one we've got some good tools there to have by default use the model reference set, which is common again for rolling up the right solids that want to show up. You want to participate in the top assemblies. But we have some good tools there to set some hierarchies there and do things if you have parts coming in from vendors and so forth that may be coming in using other reference sets. If you have large assemblies, you may want to avoid doing the associative expressions out there, using the customer defaults to turn on associative expressions. And I'll tell you why. The associative expressions, or expressions in general, require loading the expressions partition, which is a part of the NX part file out there. And that expressions partition is a little heavier piece of the part file that's not loaded as part of things like minimal loading. And so if you've minimally loaded assemblies, they load very quickly, of course, super quickly. And that's great. And you can do a lot of mass property stuff with assemblies minimally loaded. If you're updating associative expressions out there for the parts, they're going to need to load more of the part than the minimal load. And that's going to require a little heavier load, right? Sometimes a lot heavier load if you've got very, very large assemblies. So that's one to keep an eye on. Again, if you've got very large assemblies there, you may avoid setting that customer default for associative expressions. Right? Assertions. A couple things on assertions really quickly. As it says here, you're going to want to aim for the lowest possible level out there. You can assert mass properties at subassembly levels, and that works well, but assertions at the individual component level are going to roll up easiest and roll up most consistently as components get reused again and again. Asserting those properties at the part level is going to be a little more consistent, because as you assert at the at subassembly levels, those end up being instance attributes that are specific to individual instances, so they don't roll up quite as well. But anyway, the last little bit here, again, understanding the level of precision that your design requires. That's a good thing to know. I recall a conversation with a shipbuilding customer who was laying out a vessel that was as long as multiple football fields, wherever in the world you play football. It was that big, and they were a little wrapped around the axle, no pun intended, above looking at the precision of the calculations, and very concerned about what was happening 8 and 9 decimal places down in the inertial properties. And the reality of their design and the magnitude, the size of their design was that, a rainy day at sea out there with the rain water sitting on their boat was going to influence the mass of the boat more than anything they were asking me about in the 9th and 10th decimal places out there, right? The reality of the physical nature of the massive assembly that they were putting together. You needed to temper a little bit the expectations about the precision of exactly what was going to come out of NX. On the other end of the scale, of course, we have aerospace customers who are very successfully predicting vehicle inertial properties with enough precision to fly, not just the world's most interesting aircraft out there, but also fly to other planets and land some really, really cool vehicles there too. Understand the level of precision you need there, and yeah, that's an important, interesting concept. Last topic here is a little bit about licensing. What license do we need to use these new tools? The Assemblies Mass Properties management tools are going to use the same Advanced Assemblies license as the legacy tools. They're both included in the Assembly Navigator tools and the part level component mass property tools also in the Part Navigator are also included in this same license. And just for the record, this is yet another example here of significant new functionality that's been delivered at no incremental cost as part of your ongoing investment in either software maintenance or subscription licensing out there. So for customers who've had this advanced assemblies license historically, again, no incremental cost here. There's a brand new set of tools that are awesome that you are getting as part of that maintenance or subscription. These are included in our most popular our Mach 3 bundles and above, and they're also available in some other bundles out there. Also available through the value-based licensing token pool as well, as you can see here. So hope you'll enjoy using these out there. Little parting shot here, right? Again, these mass properties tools are going to support the life cycle of designs here through design and manufacturing. We're trying to preserve those numbers. Talking with customers, that's an important thing to do here, is understand how those evolve over time and be able to select those and roll up the most mature numbers, the most complete numbers as the mature designs. And then, as we said there at the bottom, really good, robust reporting tools, right? To get this information out and consume it in the ways that you need to for downstream processes in your business. Okay, so with that, that's all I have for you here today. Great to talk with you about these. Always available to talk more about the details and to help answer questions. So feel free to contact me if you have those. Again, thank you for attending Realize Live. It's great to have you with us. We get to do what we get to do because you're using our tools, and we appreciate that greatly. So with that, have a wonderful day, and we'll talk to you soon. Thank you. Bye-bye.